Hi, one of my students named Mr. Hansen asked me a question to solve a system of equation, three variables with three equations, and wanted to use Gaussian elimination method to solve this problem out. So what is a Gaussian elimination method? It has to look something like this. It has to be 1, blah, 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 and then some numbers here, 0, 1, da, 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 0, 0, 1, da, 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 da. So that's what Gaussian. You want to have zeros on this side, right over here. You want to have ones on the diagonal. That's all you need. And this is the part of the equation that you're going to solve out. So you have to get it in this form. So what we're going to do first is we're going to change this system equation into a matrix first. And to do that, all you have to do is put the coefficients for all of these. 1, 1, 1, negative 3. So let's write it out. 1, 1, 1. Put a little line right there. Negative 3. The same thing for the second equation as well. 1, negative 1, 3, and then 3. 1, negative 1, 3, and then 3. And then 5, 1, 1, 5. 5, 1, 1, 5. And what we're going to do is, with this equation right over, or matrix right over here, you have to first, step one is to get this guy to look like a 0. So what we're going to do is take the first row, subtract the second row. So it's going to be row 1 minus row 2. You could have done row 2 minus row 1, you would have got the same answer, but just to be consistent, row 1 minus row 2, and that's going to be a new row. So let's do this again. Rewrite this one. It'll be 1, 1, 1, negative 3. It's going to take this minus that, 0. This minus negative 1 is going to be 2. 1 minus 3, negative 2. And negative 3 minus 3 is negative 6. Make sure you get the system out first. Row 1 minus row 2. Row 1 minus row 2. That's how we got this guy to look like a 0. Row 1 minus row 2. 1 minus negative 1 is 2. 1 minus 3 is negative 2. Negative 3 minus 3 is negative 6. The next step is to make this guy look like a 0. And the way we're going to do that is we can either use row 1 right over here or row 2, but I'm going to use row 1. You're going to multiply the row, first row 5, 5. So 5 times row 1 minus row 3 to get your new row. Again, multiply this by 5 to get 5. Minus 5, you get 0. Do it again. Take this, the second column, multiply by 5. 5 minus 1 is going to be 4. Multiply this by 5, you get 5. Minus 1 is going to be 4 again. Negative 3 multiplied by 5 is negative 15. Minus 5 is going to be negative 20 right there. Almost done. We have to make this guy now look like a 1 as well. Remember, the diagonal has to look like a 1 and a 1 here. So I'm going to divide this by 2. Row 2 divided by row 2, divided by 2. So you end up with 1, 1, 1, keeping the first row the same. Divided by 2, you get 0. 0 over 2, 0. 2 over 2 is 1. Negative 2 over 2 is negative 1. Negative 6 over 2 is negative 3. Before I do anything, I'm going to change this to as well. Make this guy look like a 1 as well. To make this guy look like a 1, I'm going to divide it by 4. So I end up with 0. 4 divided by 4 is 1. 4 divided by 4 is 1. Negative 20 divided by 4 is negative 5. We're almost done here. I want to make this guy look like a 0 now, right? So the first step is making this guy 0, 0, 1, and then you want to make this guy a 0. To make this guy look like a 0, I'm going to do row 2 minus row 3. You cannot use row 1 anymore because then it will be non-zero. You have to use row 2 and row 3 only to get this guy look like a 0. So rewriting it, the first row stays the same, 1, 1, 1, negative 3. second row stays the same, 0, 1, negative 1, negative 3. And then 0 minus 0 is 0. 1 minus 1 is 0. Negative 1 minus 1 is negative 2. Negative 3 minus negative 5 is plus 2. Almost done. Now the last step is the diagonal has to be 1, 1, and a 1 here, right? So I'm going to divide this by 2 as well. Oh, negative 2 to make this guy look like a 1. So it's going to be 1, 1, 1, negative 3, 0, 1, negative 1, negative 3, and then dividing by negative 2, I get 0. Divided by negative 2, I get 0. Divided by 2, I get 1. Divide this by negative 2, I get negative 1. So given this information right here, we're done, basically. Well, not almost done. So the z value right over here is equal to negative 1. This value right over there, okay? So if we rewrite this equation, it's going to be x plus y plus z equals negative 3. That's equation 1. 1 right there. And equation 2 is going to be y minus z is equal to negative 3. That's equation 2. Equation 3 is z is equal to negative 1. We already got this right over here. So we have to use back substitution to find out what y is. So plugging it back in for z, we get y plus 1 is equal to negative 3 because negative of negative 1 is positive 1. So y is equal to negative 4. There it is. And then we're going to plug it back into equation 1 now. It's going to be x plus y, which is negative 4, plus z is negative 1 is equal to negative 3. X minus 5 is equal to negative 3. X is equal to 2. We're going to check our work now. The last step is checking the work. To do that, since I use equation 1 right there to get to here, it's the same equation, right? I'm either going to use equation 2 or 3. Let's use equation 3, see what happens, okay? It's going to be 5x. 5 times 2 is 10, plus y, which is negative 4, plus z, which is negative 1, is equal to what? So it's going to be 10 minus 5 equals 5. Oh, there it is. Oh, there it is. We did it right. Okay, thumbs up. So that's how you do Gaussian elimination. Again, let's do a recap of Gaussian elimination. You want to rewrite the equation in matrix format. Then you want to try to get all the diagonals to look like 1s. And the left side is 0, all zeros. And we don't care about the right side. Once, this is the hard part right here. Knowing what to do to get these zeros right here. Step 1 is to get this 0 first. Then to get this 0, the only way you can, I'm sorry, never mind about that. And then step 3 is to get that guy to look like a 0. And the only way to get this guy to equal 0 is you can only use row 2 and row 3 to try to eliminate that. And once you get all 3 of these equal to 0 and all the diagonals look like 1s, and then you just rewrite the equation. X plus y plus z equals negative 3. X minus y, I'm sorry, y minus z equals negative 3. And then z is obviously equal to negative 1. And we checked our work with the last equation and it worked out. Good luck on your test.